Hello, dear students. Actually, just kindly take a few correction based on my that video lecture, that is band structure 2. So just open, I have made that correction, and please mark it. So what I have told, like as you know, that there is called this is called my principle of band structure, and which we need to do summation over different m values. Okay. Now previously what I have done, that to calculate ni1 or n plus 1 on all these values, what I have done, I have written the component n plus 1 components of ek, that is these are the n plus 1 component, but I have mentioned the summation. The summation should not be here because I am not doing summation. Here I am not doing summation. I am doing summation over here. Summation over means when m is equal to n, that's the 1 plus m is equal to n plus 1 plus m is equal to n minus 1 component. That is the summation. Now what I have to do, I have to find the individual component. So m is equal to n, individual component is epsilon. That we have discussed nicely. What will happen, m is equal to n plus 1, that I have discussed in this section. And this section, if you consider nicely in my previous lecture, so I have told that there is a summation and everything. No, summation would not be here. Kindly mark it nicely, because I am trying to find the individual component, and then as a part of the whole summation of this principle of band structure, I need to add it. So this is the actually finding process of principle of the component of n plus 1. So there should not be any summation. So kindly correct this one. Similarly, kindly correct n minus 1 also. You see, like as I told you just now, that this is the principle of that whole, this formula is having that summation. That means I have to sum the m is equal to n, m is equal to n plus 1, and m is equal to n minus 1, right? And m plus 1 I have corrected. Similarly, n minus 1 I need to correct, and there should not be any summation over here. Correct? So I have removed this the summation symbol over here. So kindly correct it and mark it over there. And final summation will be here only. So as a part of the summation, when n is equal to m is equal to n, that is h n n. When h is equal to h n n, so you see h n n, and what is the phase factor over here? Because m is equal to n, so dm minus dn is equal to 0, because m is equal to n here. So this phase factor would be 1. So the component for m is equal to n is epsilon, plus the component of n plus 1 is e to the power ik. Definitely there should be t. Again I have missed it, sorry. Okay, let me correct here. So multiple corrections coming, I'm sorry, but it's important that we have to follow all these things. And here, yeah, so this is actually HNM e to the power ik. That's the component of n plus 1. Okay, and that we have presented here. So this is actually individual box. Sorry, this is my individual box. You can consider it actually, which is giving n plus 1 component. Similarly, this is also another component, n minus 1 component. There definitely there is no summation factor. Okay, so just correct it. Okay, so summation would be, once we find out all the individual component, then we will do the summation. Okay, so sorry, this is my final thing, this is my final, and n minus 1, I think now it looks nice, and I hope it's correct now. Okay, yeah, so this is the fact. So you can see that as a part of the summation epsilon, and their phase factor is 1, because dm is equal to dn, so we put it over there. H and m components, because nearest neighbor interaction, and the component of the nearest neighbor interaction, the component of H matrix of nearest neighbor interaction that you can put as a t. So t to the power ik, that is n plus 1 component. Similarly, t into the power ik. Okay, ik. Sorry. Again. Multiple level correction is coming. So I'm sorry, multiple level correction is coming now. So this is so h and m is t. So we put t over here, e to the power ik. Correct. So now it looks like fine for us. Okay. So sorry and thank you. Please correct it. Okay. Okay. Thank you.